So we can calculate the number of states, that means the number of modes in the volume d3k, by this very simple expression, which is the product of this one. And consequently, if we move to spherical coordinates here and we take into account the dispersion relation, then we get the total number of states in the angular frequency interval d omega here. And this is what we have calculated previously. That means this helps to transit from the discrete summation to the continuous one. Why this is important? Because this is the only way to get rid of this external parameter b here. But we have to notice that this is valid whatever the volume v, provided that, of course, all the wavelengths of the photons are very small compared to the box. This is an extremely important condition. Consequently, we can handle a larger number of photons in a given box. We can get rid of the box in our calculations, and we can get physical results. But we don't really have a real representation of the vector potential of a single photon, which remains a mystery. So, to understand this, we have to go back to the general solution of the vector potential, which is obtained by Maxwell's equations, and we notice that the dimension analysis gives that it is inversely proportional to time and consequently proportional to the angular frequency. So this is an important information, a physical information, which is general for all the vector potential expressions. Consequently, we can denote for a single photon the vector potential amplitude to be simply the product of the angular frequency times the parameter, which is a constant psi. Okay. By this way, automatically we complete the fundamental wave-particle relations for photons, which are extremely simple. They are given here because they describe both the particle properties, which is the energy, and of course the momentum, and the wave properties, which is the vector potential amplitude here, okay. The wave vector, okay, and the dispersion relation. So these simple relations relate all the physical properties of a photon as a single particle, in which, of course, we have introduced for the first time the vector potential amplitude, which was missing. Okay, so this is very important because we can see that the real existence of a photon, that is for light, is simply the angular frequency here. If the angular frequency is 0, then everything is 0. The energy, the momentum, the vector potential, the wave vector, everything disappears. Oh, really? How many? So, okay, I'll go fast. Well, if we use the vector potential expression here within the wave propagation equation, then we can get directly the vector potential amplitude operator here, which of course gives the opportunity and the possibility to define for the first time, of course, this quantum equation, which is a Schrödinger-like equation, in which, of course, we have used the vector potential amplitude operator that we have calculated. Psi is the quantization constant for the photon, of course, and now the vector potential here, which is the main, of course, function, behaves as a wave vector. That means, it behaves like a real wave function. So this wave function is real, and so we can get a non-local representation of a photon, which means that it is not a point particle. This is extremely important. And by the same time, we can see that this function here, of course, is composed by the capital psi function here, which does not disappear when the angular frequency gets 0. And by the same time, we can say that this is assimilated to the quantum vacuum, which means that the quantum vacuum is the main structure which reproduces all the photons. Either it is by spontaneous emission, either it is by stimulated emission. Also, we have calculated during different theoretical calculations the condensation constant psi for the photon vector potential here, which is about 10 minus 25 volt per meter second square. And notice that this quantization constant, which of course is the main essence of the vacuum, has also an electric essence. So in quantum mechanics, as in classical theory, the vacuum has an electric essence. This is extremely important. And this is also the main reason for which it is involved directly in the expressions of the electromagnetic waves and of the photons. Now, to sum up the conclusion, we have shown that with the quantization of the vector potential amplitude, we can get a Schrödinger-like equation here, for which the vector potential is a real wave function. This is important because for the moment we don't have a real wave function for the photon. Now, what is also important is that the vacuum component, well, here it is rather confused in transparency. Well, in the vacuum component, psi 0 is the real component which generates all photons in the universe. And finally, we can say that the vacuum is not a real sea of photons, as it is already predicted by quantum electrodynamics, which leads to the well-known singularity of quantum electrodynamics, which is that of the infinite energy of the quantum vacuum. Okay? This is what we call actually the quantum vacuum catastrophe. You are an astrophysician, you know it. And we are trying to find with which way we can get rid of this singularity, which is infinity, of course. And with this method that we have developed in Saclay, we can show that the energy density of the free space in the universe is extremely has an extremely low value, which is rather compatible with the recent astronomical and experimental observations. Now, we can say that the vacuum, well, the quantum vacuum or the vacuum in classical energy plays an important role because it creates light and it is everywhere in the universe. So we have some ancient, of course, aspects of this through which God is light and God is everywhere in the universe. And this is rather a similar aspect. If you replace the name God by quantum vacuum, you see, you find exactly the same expression. And this is not really a Christian expression because we can find it in many religions and in many ancient texts. So, in a few words, quantum vacuum coming from quantum electrodynamics has an electric nature, and of course it gives rise to all the energy of photons. Okay, all the photons are issued from the quantum vacuum. But if we use another theory which is complementary to this one, it is called quantum chromodynamics, we can also see that quantum vacuum, that means the free space, may emerge particles, okay, of different types, of different charges. So vacuum has an extremely complex structure that we are trying actually to understand. That it is the source of matter and energy in the universe. So the philosophical also ancient concepts may be, of course, discussed to see if this concept has any relationships with religious or, of course, philosophical aspects, because the main notions are extremely close. So, thank you for your attention.
Thank you very much to Konstantin Mays for this nicely technical talk. It's time for just a few short questions, please.
See, excuse me. Your selection of the topic was something special, super, congrats, first. But I got a few questions. You told epsilon 0 and V0, it is for the vacuum. Am I right? That energy equation, can you take the side number 1 total energy equation? Mm-hmm. That. Okay. Now, how can you call V as an external parameter then? Number 1. The second question is, how did you get that linear relation? Linear relation you have written primarily coordinates. And
the situation in this field is quite clear and very simple. Okay, when the angular frequency is 0.
No, I didn't ask that one. I asked that in that equation you have written mu0, epsilon0 that belong to vacuum. Am I right?
Yes.
Then V, that parameter V, how can you call that parameter as an external parameter, number one. Then the last question is, when time t equal to 0, what is the value of the total energy?
Okay, I go back to transparency. Just tell me which
Please
one.
take that equation.
Sorry?
Equation, please take that equation. The first equation, I think slide number 1 or 2.
Number 1 or 2. Okay.
Yeah.
Oh, in the classical description.
Yeah, classical description. Here. That one. See, you have written WCT, RT, that EA, RT. Okay, when time t equal to 0, what will be the value of WC?
Where what? I'm sorry?
When time t, in that equation, time t equal to 0, you put.
No, I don't put time t equal to 0 here.
Then what will be the value? Just put the value.
The time is not 0 here.
No, suppose the time is there, but suppose time is it could be 0. Then what will be the value of that? Now, what will be the value of the energy? It's got some value. In that case, then that argument of vacuum energy, see, there's some contradiction.
No.
Okay.
First of all, the time is not 0 here. Okay, this is a time-dependent equation. So the vacuum involves here simply by the constants epsilon 0 and mu 0. That's all. Okay, and the time here, which is involved in the sinusoidal expression of the electric and magnetic field, we can get rid of this when we take the mean value. So this is a time-independent equation.
Okay, so
you can get rid of it. Well, this is the main problem for quantum electrodynamics. For which reason? Because we have tried to link two opposite aspects, the wave and the particle. By doing what? By taking the mean value over a wavelength of a photon can be of a macroscopic dimension. For example, the 21 centimeters wavelength of hydrogen, which is detected in astrophysics, of course, it's a macroscopic dimension. 21 centimeters is not a very small one, so you don't have to confuse photon with a small particle, okay? Because for wavelengths of very important size, we cannot conceive a photon with less dimensions than that wavelength. So what we're doing in quantum electrodynamics, we're taking the mean value over a wavelength, and we attribute it to a point particle, to a single photon. How? By this expression here. Okay, this is attributed directly to a single particle. So it is a mean value over a wavelength and over time. And this is the reason why in pure quantum electrodynamics we cannot describe a photon, because it is considered to be a single particle, dimensionless particle, consequently a point particle, which of course actually is not confirmed by the experiments. All the experiments have demonstrated that to conceive a single photon state, we need to conceive at least a wavelength which is important in many cases and can be macroscopic.
Well, okay. I think we should move on. Thank you very much again to Constantine Mays. So our next speaker is Carlos Puente, one of the chairmen of this morning. He received his PhD from the Massachusetts Institute of Technology and has been professor at the Department of Land, Air and Water Resources at the University of California, Davis since 1986. He's the author of 3 books, and he will talk to us about from dissipation to conduction and from darkness to light. Please.
It's an honor for me to be here and delivering this talk. To set the stage, it is pertinent to introduce a game of chance that uses 2 simple maps from the plane to the plane. As there are the only equations needed to follow this talk, allow me to describe them to you. First notice that the x components are decoupled from the y components, while w sub 1 just divides the value by 2, w sub 2 divides by 2, and then adds to it 1/2. Second, observe that the y components for both maps are linear combinations of the x and y values. While the parameter d sub 1 multiplies the y value on the first map, the parameter d sub 2 does so on the second map. Now some specifics. While w sub 1 takes the point 0, 0 into 0, 0, and w sub 2, 1, 0 into 1, 0, w sub 1 takes the point 1, 0 into 1/2, 1, as indicated, and w sub 2, 0, 0 also into 1/2, 1. This means that w sub 1 operates to the left and w sub 2 to the right of the domain, which is from 0 to 1. To illustrate the so-called chaos game, select d1 equal to 0.5 and d2 equal to minus 0.5. Then place yourself at the middle point as shown and flip the coin to decide which map to use. Say you use w sub 1 if heads and w sub 2 if tails. Imagine that heads happen first. Then you use the map w sub 1 to find a new point to the left as marked. Toss the coin again and say heads happen again. Then you move from where you were into the other point shown to the left. Then toss the coin again and imagine that this time is tails. Then you move from where you were into the point shown on the right using w sub 2. The question is, what is obtained repeating this game many times? Here it is what is found after 100 iterations, and this is the final answer after about 10,000 iterations. As if by magic, the bombardment of points produces a wire, a function, a mountain profile, and this happens to be irrespective of chance and of the type of coin that you use, either a fair coin or a biased coin. It happens that these ideas yield other interesting shapes depending on the signs of d sub 1 and d sub 2, as shown when their magnitudes are equal to 1/2. The case plus minus here on the top left corresponds to the previously shown mountain, and the case minus plus is the same but flipped. Case minus minus below yields a symmetric unnatural mountain, and case plus plus produces a symmetric cloud. As shown here, comparing the profiles for values of c equal to 0.5 and c equal to 0.8, the ones on the right require more ink. Indeed, such convoluted wires fill more space and their lengths become infinite. These sets, all duly connected, are topologically one-dimensional, but as they fill up a space, they may be assigned dimensions, which, depending on z, may be any number between 1 and 2. Although the chaos game always yields the same set, the use of a fair or a biased coin generates distinct textures on the set. As illustrated here for the plus-minus case, the mountain, a fair coin results in an even distribution of points over the object. But a biased coin says one that goes heads and tails according to a 70-30 proportion induces a thorny texture that reflects the bias towards the left side. Realizing that the iterations generate not only a wire, but also a texture, it becomes relevant to ask how such a texture looks when projected into the x and y axis. Let's see it first over x. The genesis of the spikes, singularities, is illustrated here. Before the iterations start, the domain is represented by the horizontal element above. But once the game takes place, the left side is more likely used due to the proportion 7:30, and that yields two rectangles with different heights. Then, as the same coin is tossed again, the rectangles split in the same proportion, and so on. This process generates a cascade that eventually leads the object shown below, which, as seen, contains thorns arranged by layers, spikes that are so sparse that they are supported by dust. It happens that these ideas are also related to the way turbulence happens in the air. When the inertia subjugates the fluid's cohesion, as indicated by the Reynolds number on the right, the air breaks into an irreversible chain of inwardly rotating eddies that progressively divide into eddies, which lead to an arrangement of eddies that conform precisely to the 70-30 proportion. Surprisingly, observations of turbulence along a line are universally consistent with the permutation of the spiking object shown here, leading to thorns of energy that eventually dissipate in the form of heat. Curiously, but perhaps more surprisingly, this process, driven by the selfish and devilish inward spirals of the power of the air, and of course I'm citing Ephesians chapter 3, and yielding an object so fractured that it is well named a multifractal, is also useful for describing the wealth inequalities of nations, and in particular the one in the United States. Now, with the projection over X understood, we may study now the projection from the other direction. In the spirit of the discussion, here it is a wire and the corresponding histograms over X and Y, denoted by dx and dy, while using a 70-30 coin. While the X is the previously described blueprint of turbulence, the rather complex-looking derived dy may be understood in Platonic and physical ways as follows. If we think of the wire as a system from X into Y, its output may be thought of as a shadow cast by the wire when illuminated by the input dx, in a manner that resembles Plato's notions in the famous allegory of the cave. As the united wire is also a function from X to Y, then a derived dy may also be thought of as a physical transformation of turbulence, one that rearranges the energies in the original eddies. This construction represents a novel vision to approach natural complexity as a seemingly random object, dy, in reality is entirely deterministic and is only encoded by a few parameters. The notions represent a romantic Platonic idea in this day and age, that is in the 21st century and after quantum mechanics. But we have been playing with these concepts, and we can indeed generate interesting types of complexity without invoking chance. Those geometric ideas have sustained my research, but there is even more, as we may study what happens in the limit when the key parameters reach their maximum possible values. So, for a wire with d sub 1 approaching 1 and d sub 2 minus 1, that is the case plus minus, here is the surprise that follows. The wire grows and fills the space from minus infinity to infinity. Its graph acquires a dimension that tends to 2, and in the process, it transmutes the thorns over dust in the input multifractal into a smooth Gaussian bell with a finite center. This wondrous result happens to be universal, as bells are found from the same wire, not only using fair or biased coins, but also for any discrete input dx, including objects defined over dust. I'd just like to remind you that we were told, dust you are, and to dust you shall return. And I'm talking about dust here. As these results imply a non-intuitive transformation of the dissipation of turbulence into the conduction of heat, implicit in the bell via Fourier's law, and not the other way around as in the common passage from order to chaos, this discovery urged me to think about the ultimate meaning of a limiting wire capable of converting spiky violence into diffusive calmness. As dividing the limiting wire into pieces also yields projections that are bells, I finally concluded, though resisting the unscientific thought at first, that such a space-filling transformation was somehow related to love. For what else could transform dust and dissipation into something harmonic and conducting but love? It is worth noticing that when both parameters are negative, it's important to pay attention to the signs here. Positive, negative, negative, negative. Now, the construction does not define a single bell, but rather oscillations between two bells. When both D sub 1 and D sub 2 approach 1, a fractal wire shaped as a cloud is found, and the Platonic ideas define yet another bell universally, but now one that is centered at infinity. What is shown here is not the limit, but what is found when the parameters equal 0.99. As such tends to 1, the bulk of the cloud elevates to infinity, and the mean, the center, and the variance, the spread of the projection over y, both tend to infinity. But the square root of the variance over the mean tends to 0, indicating with all probability the limited presence of an infinite spiky bell at infinity. Here we may see, in a mystical manner, that this powerful wire, maximally positive and also as thick as two-dimensional space, raises it all to the clouds, filtering any kind of disorder, thorns, and dust, except for a discrete input, into an improbable condition of plenitude without entropy, just reflected by the melodic bell. How not to recognize here, in a majestic limit that takes darkness below to light at infinity, a manifestation of freedom and divine love? How not to appreciate here an essential call to the eternal? For in the directionality of the diagram, from X into Y, we may exclaim with St. Paul, where, O death, is your victory? Where, O death, is your sting? In this very spirit of redemption, how not to celebrate a truly splendid diagram, one illuminated by the just equilibrium of a fair coin that completes a majestic trilogy? For here we may witness, symbolically, and with due humility, the Father, powerful in heaven, conducting and diffusing perfect love, the Son, always constant, and the geometric solution of filling the valleys and cutting the mountains, as Isaiah and John the Baptist spoke about him, and the Holy Spirit that proceeds from them both and whose love transforms us if we allow it. Based on this limiting diagram, we may reflect, among many other things, on the lovely encounter between St. Augustine and the little boy at the beach. You remember it, right? As the transformation herein is capable of taking all the ocean on the black rectangle into a single point centered at infinity, the little boy was hinting at an unlikely possibility, little bucket by little bucket, in order to explain the mystery of the Most Holy Trinity to the saint. I don't have the time that I would like to explain things in detail, but I want to show you a very simple construction of the transformation that has to do with the plus case. The take-home exam is that plus means forward, never backwards. And the step is one unity. And I hope that this resonates when you listen to the priest say, on the unity of the Holy Spirit, because this transformation is precisely that. So this has infinite unity in it. What you're looking at is not the final object. This is for a value z, which is equal to d1 and d2. But when that value z tends to 1, everything is going to go to infinity because it goes at the first level z, at the second level with c squared, at the third level with c cubed. So basically the cloud, as I mentioned before, elevates and goes all the way to infinity. I think what I'm going to do is I'm going to end reciting for you a poem that summarizes the talk and inviting you to read the rest of the presentation that goes with the slides so that I don't rush and give you information that will be lost, realizing that we only have 3 seconds. So I'm going to jump all the way. Presentation ends with something called the antidote. So there is the X and there is the Y. Coincidentally, the X is shaped as the cross, and the Y is shaped as the one crucified on the cross. That's the directionality. So the poem says, from X into Y, as unnatural flow, mapping immensity, leaving dust below. From X into Y, only a tiny piece, wired to totality, or normal release. The Gaussian, the veil, is also known as the normal. From X into Y, or infinite fleece, by packing vitality, no thorns, but peace. From X into Y, singular the dough, symphony of unity, breathing single row. From X into Y, from holy plateau, perennial immunity, or spirit on the go. From X into Y, triune is the cell, omnipotent divinity, or sacred God's bed. There is more, but I don't have time to show it to you, but isn't the limit, following the conversation and the spirit of the presentation where beauty resides. These are lovely compositions of 2-dimensional bells in forms of crystals. If you don't take the limiting value all the way to a value of 1, what you get is something that doesn't crystallize, that shows very fuzzy things. But if one goes to the limit, and the invitation of the talk is go to the limit, that is where love is found, beauty appears. And I think with that, I end.
So many thanks to Carlos Puente for his talk, taking us from chaos to order, from darkness to light, maybe even from the impossible to faith. Any questions? No questions? Well, then we break now for coffee, and I guess we reconvene in about half an hour. 20 minutes. 20 minutes. Okay. Thank you.
Como